A lot of engineers today are under pressure to reduce cost and weight in their power systems. Copper bus bars are great electrically, but they are heavy and expensive. Aluminium is lighter and cheaper, but it brings its own risks at the joints. That is why more engineers are starting to look at CCA bus bars. CCA means copper-clad aluminium, and in this video, I will explain what that really is, how it compares with pure copper and pure aluminium, and in which types of projects it actually makes sense to use it. So let's start with the basics. What exactly is a CCA bus bar? Structurally, it is very simple. Inside the bar, you have an aluminium core. This takes most of the volume. On the outside, you have a solid layer of copper bonded to the aluminium. You can think of it as an aluminium bus bar wearing a copper jacket. The aluminium core gives you lower weight and lower material cost. The copper skin provides a familiar contact surface for bolted joints and terminations, and it improves surface conductivity compared with bare aluminium. In most constructions, the copper and aluminium are metallurgically bonded, so it is not just a loose layer that can peel off under load. Now, how does CCA compare with pure copper and pure aluminium? Let's look at for simple points: conductivity, weight, cost, and joints. For conductivity per cross-section, solid copper is still the reference. Aluminium is lower, and CCA normally sits somewhere in between, depending on how thick the copper layer is and how the bar is constructed. For weight, copper is clearly the heaviest and aluminium is the lightest. CCA is in the middle because most of the bar is aluminium. For material cost, the picture is similar. Copper is the most expensive option. Aluminium is the cheapest, and CCA sits in between. You save some copper, but you still pay for the copper skin and the bonding process. The really interesting part is at the surface and at the joints. Pure aluminium bus bars need very careful surface preparation and joint design. Otherwise, you can get high contact resistance, local heating, and long-term creep. With CCA, the outside is copper, so the bolted connections behave more like what you are used to on a traditional copper bus bar system. So, where does CCA actually make sense as a material choice? First, it can work well in low and medium voltage systems with many joints. Think as battery cabinets, power distribution, panels, and UPS systems. In these projects, you often have a large number of bolted connections. You want to reduce copper weight and cost, but you also want reliable contacts. CCA lets you keep a copper surface at the joints, which simplifies design. Second, CCA can be a good compromise in indoor systems with controlled environments. That means no heavy salt spray, no harsh chemicals, and limited pollution. In such conditions, the copper skin helps to protect the aluminium core. Third, it can be useful when you need both weight reduction and familiar connection technology without going fully to aluminium bus bars. But CCA is not a universal solution, and there are cases where I would avoid it. For example, in systems with extremely high fault currents and short-circuit forces. Large switchgear with very high kiloampere ratings is a good example. In that kind of project, solid copper still has the longest and safest track record. I would also be careful in very harsh outdoor or chemical environments, where corrosion risks are high and temperatures fluctuate a lot. Finally, in projects with very conservative standards or certification bodies, it may simply be easier to get pure copper accepted without long discussions. To summarize, CCA bus bars are a hybrid option between copper and aluminium. They can make sense in indoor cabinets, UPS, and power distribution systems, where you have many connections and you care about weight and copper cost. They are not the best choice for extreme fault levels or very harsh environments. If you are working on an ESS cabinet, a power distribution panel, or a similar system, and you are not sure whether copper, aluminium, or CCA bus bars make more sense, you are welcome to reach out with your single-line diagram or bus bar layout. We can look at it from both the engineering and the material supply side.